Hi, the question that I'll be solving goes as so. When the polynomial mx cubed minus 3x squared plus nx plus 2 is divided by x plus 3, the remainder is negative 1. When it is divided by x minus 2, the remainder is negative 4. Determine the values of m and n. So since we have what the polynomial is being divided by and its remainder for that, we know that we're going to be using the remainder theorem to solve this problem. So what exactly is the remainder theorem? Well, the remainder theorem states that when a polynomial function p of x is divided by x minus b, the remainder is p at b. So essentially, the polynomial function, when b is plugged in as x and solved, will equal the remainder. Firstly, I will let p of x equal mx cubed minus 3x squared plus nx plus 2. So the two conditions that the question gives are that when p of x is divided by x plus 3, the remainder is p at negative 3, since x plus 3 is also x minus negative 3, and in this form you can clearly see that b is negative 3. So the question says that the remainder when p of x is divided by x plus 3 is negative 1. And according to the remainder theorem, that means that p at negative 3 is going to equal that remainder, negative 1. Then the second condition is that when p of x is divided by x minus 2, the remainder is p2, since b is 2. And thus, using the same logic as above, p at 2 equals negative 4. So that's the remainder. Now that we know p of negative 3 equals negative 1 and p of 2 equals negative 4, we can set up p of x by writing this polynomial function when x equals negative 3 and the output is negative 1, and then again, but when x equals 2 and the output is negative 4. So we'll start that by stating solve p of negative 3 equals negative 1. And then we're just going to say p of negative 3 equals and let x equal negative 3. So we're going to have m times negative 3 cubed minus 3 times negative 3 squared plus n times negative 3 plus 2 all equal to negative 1. Then we're just going to multiply that. So negative 3 cubed times m is going to be negative 27m. Then negative 3 times negative 3 squared is negative 27. And then negative 3 times n is negative 3n plus 2 equals negative 1. So then we can write that as negative 27m minus 3n, negative 27 plus 2, which is going to give us negative 25 equal negative 1. Then we're going to move the negative 25 to the other side by adding it to negative 1, and that'll give us 24. So we have negative 27m minus 3n equal 24, and that's a bit hard to work with, so I'm going to divide each term of the equation by negative 3 to get an equivalent equation that's easier to work with. So I'm just going to rewrite it, but then dividing each term by negative 3, like that. And what that'll give us is 9m plus n equals negative 8. And I'll call that equation 1. Now we're going to be doing the same thing, except for p of 2 equals negative 4, and I'll start by stating solve p of 2 equals negative 4. So I'm just going to let x equal 2, p of 2 equals m times 2 cubed minus 3 times 2 squared plus n times 2 plus 2 equals negative 4. And that'll give us, when you multiply 2 cubed by m, 8m, then negative 3 times 2 squared minus 12, then 2 times n equals 2n plus 2 equals negative 4. And Then I'm going to add negative 12 plus 2, so we can write it as 8m plus 2n minus 10 equals negative 4. Now I'm going to move the negative 10 to the other side by doing negative 4 plus 10, and what that'll give us is 8m plus 2n equals 6. So that also seems a bit hard to work with, so I'm going to divide this entire equation, every term, by 2. And I'll just rewrite it, 8m plus 2n equals 6, and then every term over 2 to get an equivalent equation. So what that's going to give us is 4m plus n equals 3, and I'll call that equation number 2. Now we're working with 9m plus n equals negative 8, and 4m plus n equals 3. And we decided to call this one equation 1 and this one equation 2. So we have two unknown variables in each one, being m and n, meaning that we can use the method of elimination. And basically what this does is we're going to add or subtract these two equations in order to eliminate a variable and get an equation that has only one variable. So that's why earlier I divided the original equation by negative 3 to get this one, and by 2 to get this one, because now both of the n's are the same value. They're both 1n. So I can take these two equations and subtract them and eliminate the variable n. So now I'm just going to set up the subtraction of equation 1 by equation 2. So 9m plus n equals negative 8 minus 4m plus n equals 3. And this is equation 1, and that is equation 2. So first, 9m minus 4m is 5m. Then n minus n is 0, so that's the variable being eliminated. And then we have negative 8 minus 3, which is negative 11. Then we're going to divide both sides by 5 to solve for m. And that'll give us negative 11 over 5. So now we know the value of one of the unknowns, m. So m is negative 11. Therefore, m is negative 11 over 5. Then I can choose either equation 1 or 2 to plug m into and algebraically solve for n, which doesn't require elimination. So I will choose equation 2. And equation 2, I'll just write it down again. 4m plus n equals 3. And then I'll state let m equal negative 11 over 5. And I'm just going to plug in negative 11 over 5 as m. So 4, and then bracket negative 11 over 5 plus n equals 3. And 4 times negative 11 over 5 will be negative 44 over 5 plus n equals 3. And then we're just going to add negative 44 over 5 to the other side. So we'll get n equals 3 plus 44 over 5. And that gives us n equals 59 over 5. So now we know the value of the other unknown, m, and it is, therefore, n is 59 over 5. To recap, I used the remainder theorem with the remainder and what the polynomial is being divided by, given in the question, and then elimination to determine the values of m and n. So therefore, my final answer is that the value of m is negative 11 over 5, and the value of n is 59 over 5. And I'll box my final answer.